Welcome to MAKE, Hands-on Intro to Engineering Design, a course taught at the University of South Florida. This tutorial discusses assemblies and assembly constraints. Hi everyone, today we're going to continue on working here with the MAKE course instructional tutorial videos. Today we're going to be working on making assemblies, so I'm going to introduce that. If you notice here, I have on the screen all of the parts that we made in some of the previous tutorials. So I've colored them so that once we put them in our assembly, you can differentiate between them. But here are all the different parts that we made in the last few videos. So we're going to start by creating a new file here, a new assembly. We can do Control N, and if you go down here to the assembly section, we can just do our standard millimeter IAM file and hit create. So this will bring up a new file. Everything looks fairly familiar. The navigation controls with the little cube are the same. You have your assembly tree explorer here, and once we add some parts you'll be able to see those. Again, we also have the origin, which gives us all of our X, Y, Z, all of our orthogonal planes, as well as the X, Y, and Z axis and the center point. So to create an assembly, you first have to place some parts in to the working area here. So I can just go here and click place. It'll bring up a file open dialog. I'm going to go here and select our first part, which is going to be our stepper motor. I'm going to go here and hit open, and this is going to give us the stepper motor. What I can do is, if you see as I move my mouse around, the outline of the stepper motor follows. To place a part, I can either click, but since this is the first part we're placing, I want to make sure that this is grounded and located in the center of the workspace. What grounding means is that once the part is placed, you can't click it and drag it anywhere else, whereas a non-grounded piece, you can move that around. A grounded piece is fixed in space, and in this case, we're going to fix it at the origin. So we're going to hit OK, and it's going to create our piece, and as you can see, it's been added. If I wanted to, I could click again and add another instance of this stepper motor, but I'm just going to right-click and hit cancel, and that'll get rid of the second stepper motor. So as you can see here, stepper motor has been placed, and now you can see it located over here in our tree view here. So now that we have the first part of our assembly placed, we can start adding some more parts and applying constraints to these. So as I mentioned in some of the previous videos, a constraint is a way to relate two parts to each other, so they'll be have a certain spatial relationship. In this case, what I'm going to do is I'm going to place another part, and what I'm going to do is I'm going to place the eccentric lobe, which is the part that actually connects to the motor. So we can hit OK and open, and as you can see, I've got the preview of the part. And what I want to do is actually rotate this around the x-axis so we have it in the correct orientation. So if you right-click, you can see you can rotate x, y, or z. And I'm going to go over here and say rotate 90 degrees around x. And now you can see we have the proper orientation of our part. So just to begin, what I'm going to do is I'm just going to click the part here, and it's going to place it. Again, I could place the second instance of this part if I wanted to, but I'm just going to hit escape, and it'll get rid of the place part. So now we have our part floating in space. If I move around, you can see that it's not really positioned in any particular spot. It's arbitrary. But what I can do is I can apply some constraints, and this will allow us to place the part where we need it to go. To apply a constraint, you go up here to the constrain button in the ribbon, click it, and this will bring up the place constraint dialog. And the interesting thing about Inventor is that it's very good about determining which type of constraint that you would want to apply. So there are many types of constraints, including a mate, you have a fixed angle, you could be tangent, or you could be you could insert a part. You can also be concentric. So what we're going to do here is, since we need this hole, since we need this pin here to be inside of this hole, we're going to make a concentric constraint. So I'm going to click on the inner surface, and you can tell that it's going to be a concentric constraint because you can see this dot dash line that indicates a center line Once that appears, then you know you're on the right surface for applying a concentric constraint. So I'm just going to click that. Then I'm going to go over here, and again, you can see the center line pop up. I'm going to click that center line, and it's going to snap right into place. So I'm just going to hit OK here. And so now our concentric constraint has been applied. But if you notice, I can rotate it freely, but it also slides up and down. So in the actual model, we want the top surface of this eccentric lobe to be flush with the top of the pin from the motor. So what I'm going to do is I'm going to go back here into the constraint menu, click constrain. I'm going to click this top surface, and I'm also going to click this top surface here. So this applied the constraint, but if you notice, it actually applied it in the wrong direction. So what I'm going to do is I'm going to select this button here this button, which will reverse the mate direction. And so now after I click that button, you can see that the two top surfaces are properly aligned. Here I can get you a better view, and now you can see those two surfaces are flush. And that's exactly what we want. So we're going to hit OK, and we're well on our way here to applying all the constraints to the pieces. So that's the first part we're going to place here. We can go up. Now we're going to place the center disc that has all of the holes where the connecting rods connect. We're going to open that up. And again, we're going to rotate this piece around the x-axis by 90 degrees so we can get it in the right orientation, and then arbitrarily place it and hit escape as we did in the previous instance. So again, it's arbitrary position, just kind of placed in space. But what I'm going to do is we're going to apply, again, some constraints to this. So we're going to click our constraint button, go over here and click this top surface, as we want these two surfaces to be touching each other. So we're going to apply that constraint, click the bottom button here, and now we can go check out our preview. And this looks good. We can get a nice side view here, and you can see that's exactly what we want. The two parts are touching, but again, if I hit apply, we cancel out. You can see that despite the fact that they're on the same plane here, it can still move within space arbitrarily. So we need a secondary constraint that's going to restrain the motion of that center disc to the hole here on the eccentric lobe. So again, we're going to go to constrain. Make sure you can see that dot dash line. Click that inner surface, and again, the same thing over here. Inner surface. Apply that. Close it, and now you can see that the center disc can rotate freely while at the same time is connected to this eccentric lobe. So this is exactly the kind of motion that we want. Notice that it's also not over-constrained, so we can still rotate these pieces freely, which is how we get all of the motion of the pistons themselves once the entire thing is connected. Alright, so now that we've placed a few of the parts, we're going to now place the first layer of the engine housing. So I'm just going to go over here and place again, open this up, rotate this by 90 degrees, and I'm just going to click and place it. Hit escape so we don't have to place a second one, and we're going to constrain this again concentrically around this disc, around this shaft of the motor. Hit apply, and then as in the final design, we have this surface actually touching the bottom surface of the eccentric lobe. So we have to position ourselves so we can click on that surface by zooming enough. Click on the surface, and now you can see the parts have been mated together. Now at this point it may not make sense as to why exactly we're placing these constraints, because we don't have the case for the project in here. So if the case were present, we would be constraining these against the case as well. But since it isn't, we have to actually ground this piece as well. So what I'm going to do is I'm going to right click and say grounded, and now that both this piece and the motor have been fixed with respect to our coordinate axes. The reason I'm doing this is because in reality we would have screws going through each one of these corners here as well as on the stepper motor, and those are going to fix these pieces in place. So to simulate that now, we're just going to set them to be grounded. So now what I'm going to do to continue on with this is to place the second layer of the engine housing. Hit OK. Rotate by 90 degrees, same old procedure, hit escape. Do our first constraint here, where we're going to constrain this again around the axes of the motor. Hit apply, and then we're going to mate this surface, the bottom surface of the second layer, to the top surface of the first layer. We're going to hit OK, finish that, and if you'll notice, now it's fixed in the right position, but it can still rotate freely. So in order to fix that, what we have to do is place the constraints that would simulate the screw or screws in the corner. So we click this circular hole, again this one, you'll see they snap into place, and now this second engine housing layer is fixed. And so now you can see we have our circular disc, which is rotating on the surface of the second engine housing layer. Here's a side view of it so you can see. Now we're going to go and place the third layer of the engine housing. Same procedure as before. Constrain this again. It's concentric with the stepper motor. Gonna say OK. We'll move this piece up a little, and we're going to mate top surface of the second layer with the bottom of the third. Hit OK, and again we have to mate these holes in the corner so that we can prevent the free rotation of the engine housing layer. Click this circle and this one, hit OK, and there you go. All three engine housing layers have been placed. So now to continue on with the assembly of the rotary engine, I'm now going to place in the pistons. So we're going to go here and select them. And again, they bring up the preview for us. We're going to rotate the part 90 degrees. And now this time, once we click, instead of hitting escape, I'm going to place the part 7 times total. And after the last part, hit escape. And so this demonstrates how you can add multiple parts to the assembly at once. So what I'm going to do here is click the constrain button, and now to allow these pistons to slide within the third layer of the engine housing, I'm going to add constraints to constrain one of the edges of the piston to the edge of the cylinder, and I'm going to constrain the bottom edge of the cylinder to the second layer of the engine housing. So we can just get started here placing these parts. I'm going to apply these constraints. So if you notice, this last part that I placed actually got placed backwards. So what I'm going to do is I'm going to cancel that constraint. I'm going to right click on the part and I'm going to do free rotate. And I'm actually going to rotate the part so I can get it more of an orientation that's appropriate. Hit escape, and then I'm going to try and reapply this constraint here. So this happens from time to time depending on the orientation of the part. So I'm going to constrain this edge. There. So now what I can do is I can go through and apply the constraint to mate the bottom faces of the pistons to this top face of the second layer of the engine housing. And so the way I have to do that is first I have to move these pieces vertically so that I can be able to select the bottom face. So we'll go here and move all these pieces up. And then rotate ourselves so we can constrain. We'll start with this one. See the bottom face of the piston to the top surface there. And if we hit apply, you can now see, let's get a better view here. You can now see that this piece slides exactly where it's supposed to. Notice it can still go beyond this physical limit, but once we put the connecting rods in, the ability of that piston to move through the engine housing will be lost. So let me just apply the rest of these constraints. Okay, so now if we get a top view here, we can see all the parts have been properly constrained. We can move them into a more reasonable position. So our assembly is really starting to take shape here now. If we get a better view. So we can see it's really starting to turn out nicely. The only thing we have left to do now are to add the 7 connecting rods between these pistons and the center disc here. So again, we're going to go here and place our components. We're going to rotate these 90 degrees. We're going to place 7 of them. So we've got 7, hit escape. And now we just add our constraints. And so for these connecting rods, there are going to be 3 constraints. There are going to be 2 concentric constraints, one for the center disc and the other for the hole on the piston itself. And then the third is going to ensure that the bottom edge of the connecting rod is flush with the center disc. So let's do our first one here. We'll go and grab the hole. We'll grab one of these holes here on the center disc, apply that, do the same with this hole and this one, apply that. We're going to close this real quick, and then we're going to show, now you can see that there is now this relationship between these pieces, and we're going to go and grab the bottom edge of this connecting rod and make that flush with the center disc. And so now you can see we've got our first actual working part, and if you move the center disc around a little bit, you can see that there's the relationship. You can see the piston move in and out, and so now we just have to do the rest of them. Okay, so now you can see we've got all of the constraints applied. When one of the pistons moves, you can see we get the motion of all the pistons there. There's still a few bugs in it. It'll get all mixed up because there's no contacting, but at this point, all of the proper constraints to illustrate the motion have been made. This concludes our tutorial. Thanks for watching.